Hello everyone. Today's topic is heating effect of electric current and we will solve the exercise. Let's start. Heating effect of electric current when current flow through a conductor and after some time you feel that the conductor has become more in temperature and means simply it gets heated and this effect is called the heating effect of electric current means when current flow through a conductor its temperature increases it's become hot and this is called the heating effect of electric current. Many examples can be seen in the real life. Most common example is the filament bulb, conventional bulb, uh, which are not being used by us because it consume a lot of energy, electrical energy. Conventional bulb has been replaced by LED bulbs and heater also is the example of heating effect of electric current. Since the resistance of the heater wire, nichrome wire, is very large, therefore the moment current start flowing through it, it's become red hot. When electric energy is supplied to an electric bulb, the filament gets heated, because of which it gives light. The heating of electric bulb happens because of heating effect of electric current. So this much about the heating effect of electric current. Means simply when current flow through a conductor its temperature increases as time passes, and this is called the heating effect of electric current. You have to keep in your mind two things. Resistor get heated and this heating effect of bulb happens because of heating of electric current. Let's move. Joule's law of heating. To understand in a better way and to have a mathematical idea, uh, let an electric current I is flowing through a resistor having resistance equal to R. We have a conductor through which resistor R and through which current I is flowing. The potential difference through the resistor is equal to V. What I have supposed? Three things I have supposed over here. You must keep in your mind there is a conductor having resistance R through which current I is flowing and across it voltage V applied. This I have supposed. Okay. The charge Q flows through the circuit for time t. This also we suppose. The electricity is flowing, it means charge is flowing. Suppose for time t it is flowing. Okay. And for better understanding, let me draw a diagram for you. This is what? This is the resistor R. Okay. Symbol I am not taken. Okay. This is the resistor R and current I is flowing. Current I is flowing in the conductor and this is you can say over here a battery. This is your battery. Okay. Current I is flowing, it means charge is flowing. Charge Q is flowing for time t. This I have supposed. Okay. The work done by the battery can be calculated by this formula. this formula. You must have studied in class 9 mechanical world. W is equal to force into displacement. Okay, here is the electrical work. Okay, both are same. This and this both are same. Here was the force, here was the displacement, but here is the voltage because battery involved and charges are flowing and therefore charge is involved. So what you can say, more the voltage, more the charges will flow, and in this way more work will be done by the battery. So we know that work done is equal to the heat produced, and this can be supposed like this can be really supposed like this. So there is no difference. More the battery will do the work, more the heat will be produced obviously. And we also know I is equal to q by t. We also know I is equal to q by t. This I have explained in the class and in the previous video as well. So this I is equal to q by t, the same as I have written over here. Okay, so q is equal to can be written it. In place of q here we can write it. We are going to write here in place of q. Over here I have written here it. Okay, what was there written? Don't get confused. I want to say that heat H is equal to V. Q there was, in place of Q I have written V into IT. Okay, and therefore here is VIT. So this keep in your mind, very important formula. And let's proceed. Here we know that according to Ohm's law V is equal to IR. So in place of V here we can write IR. So if you notice what I have done here, H is equal to, in place of this V I have written here IR. This IR you see, and IT as it is, no change. Okay, IT no change. In this way I multiply I square RT, this given with this formula, this one. Okay, from here we reached over here, equation 3. This expression 3 is known as Joule's law of heating, which states that heat produced in a resistor is directly proportional to the square of current. Square of current, you see here the square of current. This equation H is equal to I square R T. Okay, so what you see here, heat produced is directly proportional to square of the current. Here square of the current, square of the current, directly proportional to the resistance, and this resistance for a given current, and directly proportional to the time. This here is the time, this time I'm talking about, proportional to the time for which the current is flowing through the resistor. So this expression 3 is called the Joule's law of heating. Again, according to Ohm's law, I is equal to V by R. You know, we written over there heat H is equal to VIT. In place of I we can write V by R, and T as it is. Okay, simply H is equal to VIT. So V as it is, in place of I, according to Ohm's law, I have written V by R. And in this way we get the expression V square by R. Wait. V by R, here square it will be, because V into V and T. So this is another expression. You will see it in the next slide. Okay, this is also very important. Over here you can see the same thing we have got over here. Okay, same thing. H is equal to VIT. H is equal to VT. In place of I, we written here V by R, and in this way we got this expression. H is equal to V square by R T. This is equation 4. Yes, this. Let's have a quick recap of all the formulae. The first one was H is equal to VIT. This one first you can say. Second is equal to V square by RT. This is second. And numbering not important, formula important. Okay, here then I square RT. This is 3, you can say. Okay, to keep in your mind while calculating the heat produced in a resistor, this formula can be utilized according to the supplied value in numerical problem. Next topic is electric power. Rate at which electrical energy is dissipated or consumed in a circuit is called electric power. P is equal to W by T. Per second or unit time, how much energy is consumed? That is called the power. P is equal to W by T, also written P is equal to H by T. As more the work is done, more heat produced. Okay, so we have 3 formulae. I have explained you. For heat, you can see P is equal to W by T. This H is equal to P is equal to W by T equal to H by T, and in place of H, this value written, this value written, this value written, and then there is a T, there is a T, there is a T, there is a T. So what happens? The T cancel, this T and this T cancel, you get this formula. When this T and this T cancel, you get this formula. When this T and this T is cancel, you get this formula. So as we have 3 formula for the calculation of heat, in the same way we have 3 formula for the power over here. These 3 also you keep in your mind. And SI unit of power is watt. This is watt, and 1 watt power is consumed. 1 watt power is, let us define how much 1 watt is. Okay, it is important. 1 watt power is 1 watt power is, this 1 watt is consumed when 1 ampere current flowing through a device at a potential difference 1 volt. Commercial unit of electrical energy is kilowatt hour. You are familiar with this topic as you have studied in class 9 also. 1 kilowatt hour is defined as the electrical energy consumed by any appliance of power 1 kilowatt in 1 hour. So the commercial unit of electrical energy is kilowatt hour, and kilowatt hour has been taken because joule is very small amount of a very small unit of energy. It is such that you want to measure 500 kilometer distance and you using a millimeter scale. How many millimeter in 1000 kilometer? Okay, so representation difficulties, to avoid the representation difficulties we use kilowatt hour, not joule. Okay, again I am explaining you how much 1 kilowatt hour. Suppose there is a appliance at your home and its power rating is, means on appliance written 1 kilowatt or 1000 watt, both are equal. Okay, and you apply, you, it is in operation for 1 hour, means you use it for 1 hour. At that time energy consumed by the appliance is called 1 kilowatt hour, or simply it is called 1 unit also, 1 unit. Okay, 1 hour can be converted into second. So this is 3600 second. 1 hour is equal to how much? 3600 second. So you solve it and you get this value. Over here 3.6 into 10 raised to power 6 joule. Okay, because this second and this second will be cancelled. This is the exercise solution given over here. You try these solutions. PDF of this solution is also has been provided, and whatever the topic has been taught you, you apply over here and solve the numericals. For the time being, that's it.